Hey everyone. Today we're going to go over self-hosting Langfuse. So Langfuse just did their third launch week. They added some new self-hosting Terraform modules, Helm chart, bunch of stuff to make it easier to self-host Langfuse. And they also open sourced a bunch of the pro features. If you go to this diagram, you can see prompt experiments, annotation queues. This is all essentially eval, experimentation stuff that is now available on open source. So we're going to go over self-hosting and we're going to demo these features for you. If you don't know us, I'm Dan, AI engineer, and this is Dave.
I'm a DevOps engineer.
And we've been building software for over 20 years and focused on AI for just over a year now. So I'll hand it over to you, Dave. You want to talk a little bit about what you built?
Yeah, go to the self-hosting tab. So they've always had the open source, but now everything that was in the paid plan is now in the open source plan. They also made things a lot easier for you. They have a full-blown Terraform module, which will spin everything up in AWS that you need, or Azure or GCP. So for example, it'll spin up ClickHouse and Postgres and set up everything you need to run Langfuse. I wanted to just try out their modules. Like, we have our own cloud that's used. The AWS one, unfortunately, did not work for me. I had a series of weird problems where the migrations would fail and then English wouldn't come up. It just didn't work for me. Unfortunately, I didn't have time to debug, or normally if I was going to use it, I would just create a fork and fix it and just open a pull request. So then my second step was GCP, and that actually worked for me. So right now, if you go to langfuse.appvitals.com, that is running on GCP.
Yep.
So that worked a little bit. SSO did not work for me. I could not get SSO to work, Dan. So by default, when you spin it up, you can create an account using username and password. There's a way of disabling it. So the way we did it is, like, I would spin it up, Dan and I would log in, I would immediately redeploy with the creating accounts turned off, but could not get SSO to work.
But I mean, all this is awesome, and we're going to really double down on it and get this working for us so we can host it in all of our cloud operations
for sure.
Moving forward using the latest and greatest. You want to talk a little bit about the trade-offs?
If you're going to deploy to your cloud, you're simply just use a Helm chart. And the Helm chart is really impressive. It has any option that I wanted, except for the SSO piece was in there. So it's very professionally built. It's being actively worked on. So if you have your own cloud, you already have Kubernetes, it's real simple. Just use their Helm chart, and it's pretty solid. They have a web server, they have a worker, they have Redis. They spin all that up for you. It has Postgres. In the case of the Terraform module, they're actually spinning that Postgres up as a service, so RDS in AWS. ClickHouse is deployed as a stateful set, and then you have like blob storage, which is, it's either S3 or Google Clouds. But all that is spun up using a combination of the Helm chart and the Terraform module. So I don't think the Terraform module is meant like to be used long term. In my view, it's just like, if you want to spin something up as a proof of concept and temporarily spin something up, and then once you figure out you want to use it, then you're going to use the Helm chart and deploy to your own cloud like you normally would. But everything worked out really great. We're super happy with it. So
sweet.
Yep.
All right. Well, let's go ahead and start exploring some of these features again. So we're going to first start with the playground. That's the easiest one to show, and then I'm going to go through annotation, queues, prompt experiments, and LLM as a judge. So this is really all about experimenting with prompts, doing evals, things like that. So let's start walking you through this. I'm just going to start with the playground here. So we are going to be working through a recipe chatbot. I chose this since all the features are eval based. This is an example repo from an AI evals course that I took, run by Hamill. He's kind of the man when it comes to evals in AI right now. So I took his course, and we're going to go through homework number 3. In this repo, it's all using Python code. We're going to migrate that to Langfuse and show you what it looks like if you were to do it in Langfuse. I'm not going to compare and contrast. We don't have time for that, but I'll walk you through some quick examples. So let's go ahead and start with the playground. Here's the system prompt. Just took it out of that repo. Super basic. If we were building this ourselves, we'd have a role, instructions, everything kind of separated out. But for this demo, this is good. I already clicked it once. I'll just click it again. This is more or less a proxy from Langfuse to OpenAI or whatever model you choose. So you can actually put your API keys in there. And when you run evals or experiments inside of Langfuse, you're going to need to set up all the different provider keys and stuff inside of Langfuse. So this is an option that you can do. A lot of times when we do evals, though, we'll build like a custom app, but I think this is going to be good just to demonstrate all the features that are now available that used to be pro only. All right, cool. So you can see this is a chef. He builds out recipes. I'm asking for a combo pizza recipe, and this is the recipe it outputs. So a brief intro, the ingredients, the instructions, all you need to build an awesome combo pizza. All right, now I want to go ahead and we're going to start looking at traces and evals. So we're going to start by doing traces. Like I said, I modified this application. So let's go over to the terminal and start looking at that.
And we've shown traces before in like all of our demos, right?
Right.
Yeah.
So nothing really new here. I just wrapped their thing and I added a couple new things.
Dan, question: there's two ways of sending traces, right? You can send through open telemetry, or through their
right.
library. So which one did you choose to use?
So this project was already using Light LLM, one of our favorite packages because you can easily switch between models or different providers, and it uses Langfuse under the hood. So I just went with that easiest way to set it up. So part of their launch week, Langfuse did a big push. They're on V3. They have more OpenTel support now, so context is automatically propagated. Light LLM has not migrated to that. So we're still on V2. It doesn't matter though for your self-hosted or the cloud platform, both work. So that's what we're running here. I showed this, I think, in the last demo. You just add the success and failure callbacks with Langfuse. You add the end variables and you're good to go. And we also are adding some trace data. So we add the query in it as the trace name. So it's really easy to identify what you're looking at. And then I added some metadata tags that we'll talk about in a little bit. That's it. Tracing setup. Now we're going to generate some traces. So this is just a little script. So one of the reasons that I chose this is it already had a bunch of example user queries. I just picked 4 different user queries that were hard for the LLM to decide what to do for the purpose of this demo. And I'll show you what that means. But since we're looking at evals and experimentation, I wanted an LLM as a judge. I wanted to be able to say, okay, this is a pass, this is a fail. So I picked some questionable queries. Usually you'd review like 100 traces and most of them would be a pass even out of the gate, probably depending on how good you were at writing your system prompt initially. But honestly, nothing special here. There's a data directory here of a bunch of different things. And I used a few of these to help get me started. So I started with this dietary query. So we're going to be focused on dietary adherence. So one of the things that Hamill talks about in his class is you want to focus on a bunch of different dimensions and write evals around each one of those dimensions. In this case, if they ask for a paleo recipe, you want to make sure that it is actually paleo compliant. So that's what the evals are going to be for this demo. Now I just need to run this real quick. So now we have all the traces in Langfuse. So now we're going to go through the annotation queue. So I already have a dietary adherence queue set up for this. We're going to throw everything in the queue, and then we're going to start processing it. So super important when you're doing evals or you start to look at your data, it's super important to look at your data, see how it's messing up, start categorizing it. All right, so this is a gluten light recipe. Just says, okay, not actually allergic to gluten, but it is kind of bothersome. And this is the recipe that it generates. So we have, let's see, chicken, lemon, olive oil. So we're looking at dietary adherence. I'm checking to make sure this is actually gluten-free. This looks good, so I'm going to pass 1. Then it'll just go to the next one, and you review all of these. So we have 4 different queries. I ran it 3 times. We want to make sure that it's consistently correct. And let's see, this one also looks
good to me.
Good. All right. Looks like, oh yeah, I'm remembering now in the homework assignment, we wanted to be strict about the recipe or how the agent was referring to gluten light. And since gluten light isn't actually like an official term for a diet, we're saying this is invalid because the agent doesn't actually know what gluten light is. So we actually want the agent, when they see or identify a restriction, to say, all right, we're going to generate a gluten-free recipe. So this is just what we decided was a product requirement. So whenever the agent actually says gluten light, we want to say that's a fail. One of the cool things about going through all your data and annotating is sometimes you'll get multiple people to do it, and then everybody will agree on the requirements for the agent. In this case, we decided that we don't want the agent to refer to gluten light since it's not actually a real thing. So I'm going to say this is a fail. And what you want to do is add a comment. So you can start categorizing these failures. So to say gluten light isn't a real thing, the agent shouldn't refer to it. It should it should provide a gluten-free recipe instead. And so this is a product requirement. It's up to your team to figure out, what is a pass or fail. Even though, this is technically the recipe is okay, we decided in this case that we don't want it to say gluten light. So we saved that. You can comment on a pass too if you notice anything interesting. So let's see, this one is avoid processed foods. And for this product, we decided avoiding processed foods should be categorized as paleo. So you can see in the metadata, I added the dietary restriction that we're auditing for. And so paleo is much more restrictive than just processed foods. No legumes and things like that. I would say, is pasta paleo?
I don't know. It's carbs.
Look, I already did this search. So no, pasta is not paleo. So since we're saying this is paleo, we're going to say actually this is a fail.
That's a fail right there.
And pasta is not paleo. So we're going to go through a bunch of these real quick. So what's this one? Okay, we know chickpeas. Chickpeas, I think, are, this is actually maybe not the best. Usually you have a domain expert do this. So we'll say this again. And really, you're going through, you're starting to categorize all the different failures here. And ultimately, what you're going to do is update the system prompt, make sure that you're improving. So you're already getting new information that, your system prompt should probably mention all the different dietary restrictions that we support, and then it should adhere to those dietary restrictions. So we're already seeing some issues here. So scrambled eggs, this one actually looks good. This one looks like it actually is paleo to me, as far as I know.
Agreed. It's paleo.
So that's a pass. And let's see, this one here, comfort food that won't make me feel guilty. So as I said, I took from their data set. This one is actually categorized as vegetarian. So this is a really tricky one for the LLM to get right, given this current system prompt. And I don't know where they got that, but they generated these. So all the user queries are all synthetically generated. They picked a bunch of dimensions. The LLM came up with this. If we were actually doing this, I would probably say this is an invalid categorization for vegetarian, because how do you spot it? So anyways, yeah, you can see here vegetarian. And this is actually one issue with the light LLM, is the metadata goes on the generation instead of the trace. So I always forget to click on that generation. But let's see what we did here. So actually, is this vegetarian? This actually is looking okay here. I would say this is vegetarian. So this is a pass. So,
although I do disagree that vegetarian food is comfort food.
How can you actually have vegetarian comfut food?
Yeah, I mean, maybe you can,
but comfort food that doesn't make me feel guilty. I mean, that's also I don't know about that. But anyways, okay, this one. You know what the LLM usually responds with is chicken, which is not vegetarian. This one looks good. So somehow the LLM is coming up with a comfort food recipe. Vegetable lentil soup. Comfort food? I don't know about that. But that's not the dimension that we're judging on right now. All right. And this is another one. Also looks like
That looks
they've got it.
vegetarian.
It
Yep.
didn't. It didn't put chicken. Chicken what is a common one. So if you were going to do more, um, in the example in this homework 3, they actually generated 2,400 traces, and they recommend that you go through 200 of them. We're only going through 12. All right, sugar-free. So the things that I'm looking for here are like honey or maple syrup or something, which have a lot of sugar. This is actually sugar-free here. It looks like, so it's a pass. And coconut oil, this all looks good. Monk fruit sweetener, I think this is actually a fail, so I'm going to say fail on this. And I'm, being over strict, but monk fruit has a lot of sugar.
I'm not 100% sure about that, but let's just keep rolling.
Yeah, me either. I'm not a dietary expert.
Yeah.
That's why you usually have domain experts do this. We're finally at the last one. Coconut oil. We have monk fruit again, so I'm going to say fail because I'm not very nice. All right. So, and really, again, this is all about you identifying what you care about in the response. And so this is really a hypothetical situation. But what you would do is like start adding these definitions into your system prompt so the LLM knows, all right, don't put monk fruit, or don't put honey, don't put maple syrup. All right, so now the next thing that we're going to go through.
By the way, that interface was super awesome and easy to use. Very intuitive, right? Like a non-technical person could, like a domain expert, could very easily go through that. Like, it's perfectly built. Great job, Langfuse.
It's pretty cool. You can just say next, next, next. Insert your annotation. It starts capturing these scores for you. You can see all the scores here and review them. And we're going to come back to this scores thing because it's going to become important when we start doing LLM as a judge. All right, so up next, we're going to go ahead and create a data set and run through some experimentations. So let's go ahead and do that. So we're going to create a data set using their SDK. And I'm going to pull the traces that we just went through. So this is the Langfuse SDK. You fetch all the traces. And the data set, you need to transform it slightly. And you'll see, but you want to transform it so the prompts that you're going to use, you actually have the variables that are inserted into those prompts. So what we're going to actually be looking at is LLM as a judge prompts. And maybe I'll run through those prompts real quick so you can get a sense of what those look like before we do this. So let's go back to Langfuse. I want to run through the prompts. So I have 2 judges here. One's a strict judge, one's a lenient judge. This is so we can see the different scores, because I really want to show, like, all right, pass, fails, and show you the difference. It's not going to be so obvious when you're tuning things. You're going to be looking at fine percentages and stuff like that. So here we go. We got the query. This is the user query. So it's that I want a sugar-free diet or a light gluten recipe, or a sugar-free recipe or a light gluten recipe. Then there's the dietary restriction. So this is paleo, whatever. And then there's the actual recipe that the LLM responds with. And then this is the JSON response. So that's the prompt. And we have 2 prompts here. We have our lenient and our strict one. So this one is just like, you're a nutritionalist evaluating, and the strict one is like, you're a strict dietary compliance specialist. It actually is calling out the different restrictions, how you want it to evaluate. So what were you looking at when you did all those annotations yourself? You're trying to put that into a prompt now. And now I'm gonna go back and create this data set so it'll make a little bit more sense as we go over it. So we pull all the traces, then we extract the data. So we pull out the user query, we pull out the response, so this is the output content, and then the dietary restriction is buried in the generation metadata. So we pull that out as well. And now I'm going to run this Python scripts, create data set. All right, so we found our 12 traces, extracting them, creating the data set. Now let's go back to Langfuse again and view that data set. So we come down here, here's our dietary adherence demo data set. You can see all the different items that I put in here. I'm on a sugar-free diet, so that's the query, that's the response, pulled from our traces. You can actually automatically add traces to a data set too. So if you go in here and you say add to data set, you can do that. But the problem is you kind of go to here, you say, all right, I want query, and then the query is this, and then I want the response. You would have to manually go through and do the formatting yourself, and then you'd have to add that dietary restriction in here manually. So that's why I automated it. But you can do this. You can just add it to the data set, and you select which one that you want, and you add it there manually. All right, cool. Let's go back to this data set. Now we want to run a new experiment. So we're going to do a prompt experiment. We're going to go over the, so we're going to do lenient judge. I'm doing V1 because it's actually, so prompts in Langfuse are versioned, and we're just going to use the model that we have configured. It double checks to make sure the data set actually matches all the parameters in the prompt, and we're not going to use an evaluator for this one. We're actually creating an evaluator. So that is set to run. We're going to let that run. I'm going to do another experiment here for the strict judge, V1, select the prompt, strict judge V1, and again, same thing, run.
So Dan, this like creating this like in the UI and also like the prompts so far that I've seen, that's the type of thing that'd be great to be able to create programmatically using like something like Terraform or something, so that it was a new version. Like, hey, we checked in a new prompt into the Git. Okay, I'm gonna go deploy this add this new prompt automatically to your Langfuse, right? Like,
yeah. Start running experiments.
Yeah, and then okay, there's a new prompt running experiment. So like, and there is a discussion in the GitHub for Langfuse to add Terraform, but like these type of things would be great just programmatically. Like, hey, there's a new prompt, or there's a new model we want to run against it. Programmatically run this thing. So
yeah,
there's definitely like a lot of like room to even make it even better. A great product even better.
Oh yeah. All right, so now we have these two finished running. Now what you can actually do is compare the two and start looking at the difference between our strict judge and our lenient judge. And we're really, so this is the strict judge is very verbose, really judgy. And this one, they both passed. All right, this one actually did not pass. Sugar-free diet, let's see. Which one? What did it complain about here? Is it the monk? What was
the monk fruit? Is the monk fruit?
All right, so this LLM is very judgy.
Yeah.
Vanilla extract. Oh, you have to verify that it's pure vanilla extract.
There you go. So it's super judgy, which is what we said, right?
So we're going with two extremes. Maybe you want something in between. You throw another one in here. You can see. But anyways.
Well, it's funny to note because like the lenient judge did pass it, right?
Yeah, so, pass, fail. Yeah. That's really what I wanted to show, and that's why I chose these prompts, because they're right on the verge of the LLM's probably going to mess up, because there's just not enough information really for the LLM to actually do the right thing depending on what it is. So 0, 1, again, we got some pass fails. All right, cool. So that is the experimentation piece, and now we're going to go through and run the LLM as a judge. So we're going to go into evaluation. So first we did this human annotation thing. That's the annotation queue. And now we're going to run LLM as a judge. So I've created 2 custom judges. We're firm believers that you really are judging your domain, and a lot of these things can be useful, but really when you're building a product, you have strict product requirements. You really often are writing domain-specific judges, which is what we did here. So we have our judge. It's the same prompt, and Now you just got to run it. We want to use this evaluator. We want to run it through existing traces. So here, you can actually see that in the traces, this is the experiment that we ran against our data set. And then these are our original traces. All right, so you can select existing traces, add a filter, any of, and we're just going to select these ones. So we get just the ones that we have. And I have to fix this slightly so it actually works. So we want the input is the actual user query. The dietary restriction is in the metadata, and we actually want it on the generation. So there we go, dietary restriction. Super nice that it has this so I can figure out what it's going to pass to it. And then this is the output, and we want the content here. All right, cool. So now we have our judge. We can see it visualized here and execute. All right, great. Now let's go ahead and run the strict judge. And we're going to be doing existing traces, add a filter, I'm going to do name, and we're just going to select all these. There's probably a better way to do this, but this is going to get it done for us. And I want to look at the metadata, dietary restriction, and yeah, if you were doing this programmatically using their SDK, just write a script.
Yeah.
But I did not write a script for this one. We're looking at the output here and content. Cool. So, and again, you can verify, all right, the query, gluten-free, etc. And execute. All right, cool. All right, what do we have here? So we're still running some of these. We've run a few. Let's see. All right, lenient judge finished. Oops. And we can go ahead and view that result. So you can see the score value here. And this is kind of the cool thing. If we go, so we go back, let's go back to LLM as a judge. We're going, okay, all those are queued up. But let's go back to tracing and scores. And now you'll see the eval score. So this is the lenient judge score that we just did. These are the human annotations. So you can see all of this stuff and kind of compare it against the two, right? So we have this trace ID. So let's look at a single trace. Great. That's how you find the score on the trace. You can see the different scores that we have. And you can see actually the lenient judge passed this. The human judge did not. Let's see if, there we go. Let's see what the strict judge said. Okay, so my annotation, who knows who's right here. I'm going to say maybe the strict judge, defer. If I'm stricter than the strict judge, then yeah, maybe that's wrong, especially since I have no idea about diets. I wish I had more
Especially
ideas about
monk
diets.
food. We're not experts on monk food, that's for sure.
So that's it. Those are all the cool features. Honestly, it's so awesome to see Langfuse having all this eval stuff built right into the open source. And yeah, hope you enjoyed it.
Yeah, so we're huge fans of Langfuse. I can't imagine working with models and not using Langfuse to develop and develop them and or just what's going on with them, how are they performing, stuff like that. And it's so awesome that it's open source and then you can host it yourself.
Yeah.
Because one of the big issues is data, right? Sending user data out to the cloud to someone else's cloud is not good, right?
Right.
It's a pain in the butt. We want to avoid that, and so thank you, Langfuse, for doing such a great job.
Right.
So to have a great product.
Yeah, and one of the things that we kept kind of going back to here is you can use the UI, you can use the SDK. Also, one of the features that we did not go over here, which would be good to maybe get this stuff into Snowflake or whatever your data warehousing solution is the batch exports to S3. So you could get it out of Langfuse, get it into your dashboards. It's all your data. You can do whatever you want with it. You can write code to mutate it, run these LLM as a judge things. You can export it to S3, load it into your warehouse. Awesome.
Yep.
So you can kind of pick and choose how you want to use it. So that's great. I think that's it for today. If you enjoyed the video,
Woo!
If you enjoyed the video, feel free to like or subscribe. And if you want to work with us, there's a link in the video. Reach out for a discovery call. Looking forward to hearing from you. All right.
Bye.
See ya.